This video is a hypothesis test for population proportion using the p-value method. A drug company provides a one-panel THC test for marijuana usage. Among 300 tested subjects, results from 27 subjects were wrong, either a false positive or a false negative. At alpha equal 0.05, test the claim that less than 10% of the test results are wrong. So we need to write the claim as a statement in terms of the population parameter P. So the claim is that less than 10%, that does not contain the case of equality. So writing that as P less than 0.10, that's the claim. That makes the claim the alternative because it doesn't contain the case of equality. And the null will be that P is equal to 0.10. So we need to first determine if the normal approximation can be used in this problem, because in this example I want to use the one proportion z-test. So to check that, I need to know if n times p is at least 5 and n times 1 minus p is at least 5. In the problem, n is equal to 300 and p is the claimed or the hypothesized value. So is 300 times 0.10, is that at least 5? Well, yes, 30 is at least 5, so that product checks. And is 300 times 1 minus p, if p is 0.1, then 1 minus p would be 0.9. Is that at least 5? Well, this product is 270. Yes, that's at least 5. So our standardized test statistic will follow the standard normal distribution. And to use the p-value method, we do need to find that test statistic. It's p hat, the sample proportion, minus the claimed proportion, over the square root of p times 1 minus p over n, everything under the square root. So we need the sample proportion, p hat. P hat is equal to x over n, where x is the number of quote-unquote successes. So looking back at the problem, 27 out of the 300 were wrong. We're calling wrong a success in this problem. It's the it's what you're interested in the problem. So 27 out of 300, and converting that to a decimal, I get 0.09. So here's what's observed from the sample, 0.09. And the claimed value is 0.10. And that's going to be over the square root of 0.10 times 0.90 over 300. Our sample size was 300. Now I expect my standardized test statistic to be negative in this situation. So inputting into the calculator, using parentheses for the numerator expression, I get a value of negative 0.577 rounded to 3. Okay, so what we want when we're finding the p-value is we want to find the probability of getting a test statistic at least as extreme as the one obtained by the sample. So because this is a lower-tailed test, looking at the alternative, it's pointing to the left, so I know this is a lower-tailed or left-tailed test. The p-value is going to be the area further to the left of that standardized test statistic. Okay, so that test statistic is negative 0.577. So this area here is going to be the p-value. Now this is pretty close to 0. I expect that p-value to be reasonably large. When you're given a z-score and you want to find an area or a probability using the TI-84, you want to use the NormalCDF function. So I'm going to go ahead and do that. So going to my distribution menu, selecting NormalCDF, my lower bound is theoretically negative infinity, but you can just put in a 1 with a bunch of zeros. My upper bound is negative 0.577, working with standard normal here. I get a p-value of approximately 0.282. Okay, so to make a decision with the p-value method, our p-value will be compared to alpha, our level of significance. Alpha is also an area, it is also a probability. When your p-value is greater than or equal to your level of significance, then you are going to fail to reject the null hypothesis. So I have my p-value of 0.577. The level of significance stated in the problem was 0.10. Oops. Sorry. What am I thinking? That's not a valid probability. This is what happens when I go on autopilot. Oh my goodness. Okay, the p-value, probability can never be negative, for one thing. Alright, so my p-value is 0.282. Comparing that to my level of significance, the p-value is greater than or equal to 0.10. I know my decision is to fail to reject the null. Okay, so in terms of a decision, looking at our null and our alternative with respect to the claim, the null hypothesis is the quote-unquote winner here. The null hypothesis is not the claim in this problem. So when we're asked to test the claim that less than 10% of the test results are wrong, okay, so there is not enough evidence to conclude that less than 10% of the test results are wrong. Okay, so looking at the calculator again, we can get the standardized test statistic and p-value directly. Now my p-value might be off just a little bit because I rounded the standardized test statistic, but it should be close, and certainly the decision would remain the same. You go to your stat menu, right arrow over to tests, and you want to select the 1 proportion z test. Put in the claimed parameter, 0.1. The number of successes is x, that was 27. Our sample size was 300. I want to change this alternative to match the problem, otherwise you will not get the correct p-value. This was a lower-tailed test. And then calculate. Alright, so rounded to 3 decimal places. It is the same as what I got. And rounding to 3 decimal places, the p-value is 0.282. So I wasn't too far off in this problem when I did it quote-unquote by hand. Okay, so whenever your p-value is greater than or equal to your level of significance, you're going to fail to reject the null. And because the decision was to fail to reject the null, it is possible that a type 2 error may have occurred.